So welcome everybody to this latest revision video on 162 Maths, and in this video we'll be continuing with the series from the AQA GCSE Maths 2022 Advanced Information on the Foundation Paper 1, which is a non-calculator paper with a focus on the geometry and measure section. Now there will be a copy of the questions that we go through in this video that you can download and work through by clicking on the link in the description. Now, before we get started on some example revision questions, let's have a look at the geometry and measure revision list for paper 1 on the foundation paper. Now, looking at shapes, it says naming parts of the circle, types of triangle, and translation. So naming parts of the circle is just knowing what other parts are. And again, beyond the X point of diameter, radius, circumference, you also need to look at tangents, chords, sectors, and segments rather. When it comes to types of triangle, it's recognizing equilateral triangles, isosceles triangles, and scalene and right angle triangles, and knowing all about their properties. Translation, you're probably looking at that type of transformation. Then you've got perimeter of a shape. Now that shape could be absolutely anything, so as long as you understand the concept of perimeters and know how to find them, particularly on compound shapes, then you should be fine. When it comes to sectors of a circle, it's a case of manipulating the area formula of a circle, which is pi r squared, divided by the proportion of the circle. So if it's a semicircle, you divide it by 2. If it's a quarter circle, you divide it by 4. And also recognizing how to work out the perimeter of a sector of a circle, and again not forgetting those straight edges. And then obviously in terms of the circumference of the circle, it's going to be pi times the diameter, and then divided by 2 if it's a semicircle, divided by 4 if it's a quarter circle. With angles in a triangle, it's recognizing that they add up to 180. And when it comes to regions in constructions, that's dealing with loci. So make sure that you're able to construct a triangle from given instructions, but also work with some loci problems. And again, if you're unsure about any of these topics, then there is a revision list linked to this particular paper that if you click on the link, it sends you to lessons regarding all of these. So if there's any of these that you're not sure about, it will teach you and go through each of these topics. So let's get started on these example questions. Now again, a reminder that if you're wanting to have an attempt at these questions or do these questions while we're watching this video, then just simply click on the link in the description below and you'll have access to a blank copy of these questions. So looking at question 1, which refers to parts of a circle, it says circle the word that describes the straight line PQ, and the line PQ represents a chord. Then moving on to question 2, it says that O is the center of the circle, and it says circle the word to complete each sentence. So it says that the line OA is A, and that is a radius, because that's what this line here is. That's part A, and that's the radius. Part B is the line MN, which is this line here, and that represents a chord. And the line ST, which is this line here, and that represents a tangent. Then moving on to question 3, it says here is a parallelogram, and it says that the parallelogram is translated 4 squares to the left and 3 squares up, and we need to draw the translated parallelogram. So if I just zoom out, so we've got that on the screen. So for this, what I want to do is pick a particular point. Let's go for this one here, and then follow the translation. I'm going to move it 4 squares to the left, so that's there, and then move it 3 squares up. So this is where the new place is going to be. Then if I repeat all the other points with that direction, then what I should find is that the parallelogram gets translated here. Now you always want to make sure that you're using a ruler, but for time purposes, I'm going to do this freehand, and that's basically where the shape should be. Moving on to question 4, it says that the vector -2, 3 translates from A to B. Circle the vector that translates B to A. Now for this, all we need to do is keep the numbers the same, but for this we are reversing the sign. So the correct answer you should have is the last option, which is 2 - 3. Then with question 5, it says that the shape is translated by the vector 0, 4. In which direction does this shape move? And the correct answer is up. Moving on to question 6, it says circle the vector that translates shape R to S. So we're going from this shape to this shape. So if I pick a particular point, so let's just call this A, and I pick the corresponding point on S, which is A dash. So then I'm just counting the number of squares across, which is 6, and then 1 down, which is 1 - 1. So I'm looking for 6 - 1, which is our second option. Moving on to question 7, it says translate this T shape to the point A to point B. So again, all I want to do here is then translate that shape, and it should look something like this. And again, any diagram you draw, make sure you are using a ruler, which I know that I'm not, so you don't fall asleep. And then the question then says describe the translation. So here all we need to do is write down the column vector. So A to B has moved how many squares to the right, sorry, it's going to be 5, and it's moved 6 down, so it would be -6. Moving on to question 8, it says that work out the area of shape A to the ratio to the area of shape B. So here all I need to do is work out the area of A, which is equals to 4 times 5, which is 20. The area of B, and again by counting the squares, and that's going to be 12. So the ratio is then 20 to 12, and then I just want to simplify that, and it's in its simplest form becomes 5/3 by dividing each of the numbers by 4. Moving on to question 9, it says that the shorter side of the parallelogram has a length of 6.5. The length of the shorter side is 1/9 of the perimeter. Work out the length of the longer side. So for this, what I need to do is, well, if 1/9 equals 6.5, then 9/9, which is the perimeter of the whole shape, is going to be 6.5 times 9, and 6.5 times 9 is going to be 58.5. So that's the perimeter of the whole shape. So then what I then need to do then is, so the perimeter, and if I call this x, and this is going to be 6.5, then basically means that the perimeter is going to be equal to 2x plus 6.5 plus 6.5, which is 13, equals 58.5. And then all I've got to do then is solve this equation. So 2x equals, and that's going to be 45.5. And so x equals 45.5 divided by 2, which is 22.75 centimeters. And there's my final answer for that one. Then moving on to question 10, it says that a large rectangle is made by joining 3 identical small rectangles as shown. The perimeter of one small rectangle is 15. Work out the perimeter of the large rectangle. So for this, all I need to do is first of all label these rectangles. So if I call this side x, and this is going to be x, and that's going to be x, then that means that the length of one of the smaller rectangles is going to be 2x. And then if I continue that labeling, then what I end up with is that. Now the perimeter of one small rectangle is going to be 2x plus x plus 2x plus x, and that all equals 15. So simplifying all of this, I end up with 6x equals 15. So x equals 15 divided by 6, which is 5/2, which equals 2.5 centimeters. So x equals 2.5 centimeters. So from this, what I can then do is work out the perimeter of the entire shape. Now working in terms of x, then what I've got is I've got 2x plus 3x plus 2x plus 3x. Again, this is 3x, that's 2x. It's the perimeter along. Now, if x equals 2.5, then what I end up with, adding all of these x's together, I end up with 10x. So what I've then got to do is 10 times x, which is 2.5, which then leaves me with 25 centimeters. Moving on to question 11, it says the triangle has a perimeter of 32 centimeters, a square has a perimeter of 40, and it says 2 sides of the shapes are put together to make this pentagon, and the question is asking us to work out the perimeter of the rectangle, of the pentagon, sorry. So if the perimeter of the square is 40, that means that each side must be 10, because 40 divided by 4 is 10. So if the base of this triangle is 10 and all the perimeter is 32, then these 2 sides here must add up together to make 22. So working out the perimeter of this pentagon, that I know that these 2 lengths here added together equal 22. This equals 10, this equals 10, this equals 10. So the perimeter equals 30 plus 22, give me a final answer of 52 centimeters. So moving on to question 12, it says the perimeter of the kite ABCD is 24 centimeters. The length of AB is 3, which therefore means that this side here will be 3. And the question is asking us to work out the length of CD. Well, if I do 24, take away 6, that leaves me with 18. Then 18 divided by 2 equals 9. So 9 centimeters is the correct answer. Then moving on to question 13, it says two 10 centimeter by 6 centimeter rectangles are cut in half as shown. And it says 4 pieces are joined together without overlap as shown. And the question is asking us to work out the perimeter of the shaded rectangle. So for this, what we need to do is label each of these points. So this is going to be 5, and this length here is going to be 10. This small length here is going to be 3. This is going to be 6, and that's going to be 5. This length here is going to be 10. This length here is going to be 3, and this length here is going to be 6. So from this, what I can then do is from those measurements work out what each of these bits are going to be. So this length here, if I use a different colour there, well, that's going to be 15 take away 5 take away 5, so that's going to equal 5 centimeters. And this length here, well, it's going to be 3 take away 3, which gives me 3. So then the perimeter of the shaded area is going to be 5 plus 3 plus 5 plus 3, which gives me an answer of 16 centimeters. Then moving on to question 14, it says 2 identical quarter circles are cut from a rectangle as shown. And the question is asking us to work out the shaded area. Now the shaded area is always going to be the big shape minus the small shape. Now in this case, my big shape is the rectangle, and the small shape is going to be the 2 quarter circles. Now 2 quarter circles is basically half a circle. So working out the area of the rectangle, now because this represents a circle, that this length here, well, if this length here is going to be 6 because it's half, that means that the base of that rectangle is also going to be 6. So the area of the rectangle is going to be 12 times 6, which is 72 centimeters squared. Now the area of the semicircle, and the formula for that is pi r squared divided by 2, is going to be equal to pi times the radius, which is 6 squared, divided by 2, and that's 36 pi divided by 2, which equals 18 pi. So then the shaded area is going to equal 72 minus 18 pi. And I'll leave my answer like that because it is a non-calculated paper. Moving on to question 15, it says that BCD is a straight line, triangles ABC is equilateral, and C to E is equal to D to E. And the question is asking us to work out the angle of angle X. So if ABC is a equilateral triangle, then this angle here is going to be 60, and so is this one, and so is this one. Now if CE and ED are equal, then that's going to be an isosceles triangle. So this angle here is going to be 180 minus 28 divided by 2. Now 180 take away 28 is 152, and if I divide that by 2, I end up with 76 degrees. So this angle here is 76, and this angle here is going to be 76. Now angles on a straight line add up to 180, so angle X is going to be 180 minus 60 minus 76. These two numbers added together gives me 136. So it's 180 minus 36, which leaves me with an answer of 44 degrees. So X equals 44. Moving on to B, it says Amber is working out the size of an interior angle of a regular octagon. Her method is 360 divided by 8. Is her method correct? Give your reason for your answer. Well, the correct answer is no. And the reason for that is because on one of the, you could give any of these, she has worked out the exterior angle, because all exterior angles add up to instead. You could also give a reason of the fact that it should be 360 divided by 6, not 8. And also that the angle, the interior angle, I should say, should be 135. Also, 360 divided by 8 is 45, I think. Let me just double check on that. 360 divided by 8 is 45, yeah. And 45 is an acute, which is an acute angle, where clearly, and this interior angle is obtuse. So again, several reasons which you could give to get that 1 mark. Moving on to question 16, it says the diagram shows a triangle ACD and an equilateral triangle of BCD, and the question is asking to work out the size of angle X. So again, with equilateral triangles, these angles are all going to add up to 60. And we know that angles inside a triangle add up to 180. So if this entire angle is 100, this angle here is 20, then 180 minus 100 minus 60 equals X. So X equals 20 degrees. Moving on to question 17, it says the diagram shows an isosceles triangle, and it says work out the possible sizes of the other 2 angles. Give both different pairs of angles. So for this, what you need to recognize is that either this angle here is also going to be 40, so I could have 40, and therefore this angle here is going to be, so if that's 40, then this angle here is going to be 100. Or the 40 degrees could be the unique angle, and these 2 angles could be the same. And so this angle here is going to be 140 divided by 2, which is 70. So either these 2 angles here would be 70. And again, you give those numbers in any order. Moving on to question 18, it says work out the size of angle X. So you should know that angles around a point add up to 360. So this needs to do 360 take away 70 minus 120 minus 40, in which you should have the answer of 130. Then for B, it says what type of triangle is ABC, and it says must show you working, which may be on the diagram. Well, this angle here is going to be 25 degrees because it's opposite. This angle here lies on a straight line, so that's going to be 180 minus 115, which gives me an answer of 65 degrees. And so this angle here, by working out angles on a triangle, must be 90 degrees. So here there's a couple of triangles you could give. So with it being having a 90 degree angle, it could be classed as a right angle triangle. Or you could say that because all the angles are different, that it's going to be a scalene triangle. And I would say any of those 2 answers would be fine to get the mark. For question 19, it says triangles ABD and BCD are isosceles, and it says angle ABC is 90 degrees, and the question is asking us to work out the size of angle X. Well, this angle here is going to be 56 degrees because it's an isosceles triangle, so therefore I can then work out what this angle here is, and that's going to be 180 minus 56 minus 56, which is 180 minus 112, so that angle there is going to be 68 degrees. Then from this, I can then work out what this angle here is going to be, because that's going to be 90 minus 68, and that gives me an answer of 22 degrees. And then to work out what angle X is, well, this is going to be X. I know that 2X plus 22 equals 180 because the angle's in a triangle. So 2X equals 158. And so X equals 158 divided by 2, which gives me an answer of 79. Then moving on to question 20, it says ABC is a right angle triangle. Work out the angle of Y. Well, from this, I can then work out what this angle here is first by doing 180 minus 90, which is 90, take away 50, which leaves me with 40 degrees. And so that means then that this angle here, because it's on a straight line, must be 140 because those two angles there add up to 180. So then angle Y is going to be 180 minus from 180 take away 140, which leaves me with 40 degrees, and that equals 2y, so y must equal 20 degrees. Now for question 21, it says that a scale drawing shows positions P, Q and R. It says on the scale drawing, P to Q is 4 centimeters, Q to R is 6.5, and it says the actual distance P to Q is 50 meters less than the actual distance from Q to R. Work out the scale. So for this, what we need to do is first of all subtract the two lengths together. So it's going to be 6.5 take away 4 centimeters, which equals 2.5 centimeters. So basically what that then entails is that 2.5 centimeters equals 50 meters. Now what I need to do is divide both numbers by 2.5. So if I divide that by 2.5 and divide this by 2.5, now what I end up is 1 centimeter equals 50 divided by 2.5. So here what I need to do is 50 divided by 2.5, which is 500 divided by 25. And how many 25s are in 100? That's 4. So it's going to be 4 times 5, which is 20. So the answer then is that 1 centimeter equals 20 meters. So for question 22, what we need to do is draw a perpendicular bisector between A and B. Now how we do that is we set our compass so that it is correctly set up first, so that when you close the compass, the tip of the pencil and the pin are as close as possible. Then you set your compass so it's more than halfway. Now it doesn't really matter what length that is, as long as it's more than halfway. You then draw an arc from A so it looks something like this. Now again, apologies if it's not coming up clearly on the camera. And then without adjusting the compass, put the pin on B, and where you're looking for is where the two arcs intersect. And what you should have is 2 intersection points, and then what you then need to do is then join those 2 intersection points with a straight line and a ruler, and the treasure can be anywhere between those two on that line. So it could be anywhere along this line here and here. For question 23, it says using a ruler and compass, show the region inside the grid that is less than 4 centimeters from A and nearer to B than C. Now for this, what we need to do is we need to draw a circle of 4 centimeters around A. So what I'm then going to do is with my ruler and my compass, I'm going to set 4 centimeters, which can be a little bit fiddly depending on your compass. And I'm going to draw a circle from A, and again can be quite fiddly, which looks like that. And then what we then need to do is we then need to do a perpendicular bisector between the lines B and C. So again, very similar to question 22, where we set our compass so it's more than halfway. So actually I don't need to adjust the compass because 4 centimeters more than halfway. And again, where I'm looking for is those 2 arcs that cross, which they do there. And I then need to draw a line through those intersection points. Now make sure that your line goes from one end to the square to the other. Now in terms of regions that's closer to B then A is going to be this area here, and it needs to be within the circle. So what I'm shading in is this region here, and that is my region R. So it should look something like that. So basically it's the circle, inside the circle and above that line that we've drawn. Then moving on to our next question, and looking at this, it says use a ruler and compass for this question. It says that a ship is closer to port X than Y. So what we need to do here is a perpendicular bisector for Y and X, and then I then need to draw a circle around Y with a radius of, now it says 11 kilometers, now 1 centimeter equals 2 kilometers. So if I divide this distance by 2, which gives me 5.5, so the radius is going to be 5.5 centimeters. So if I do the first bit first, let's do a perpendicular bisector of X and Y. So again, set your compass so it's more than halfway, like so, and then do the same from Y without again adjusting the compass. You should end up with something that looks like this. Then with your ruler, draw a straight line. Now it says that it's got to be closer to port X, so I'm looking for this side here. Now I then got to draw a circle of 5.5 from Y. So looking at my ruler, measuring 5.5 from the pin to the pencil from Y, and I'm drawing this circle here, like so. And so where could the buried treasure, oh no, where could this label this region as well as R? So basically what I'm looking for, well, if I just complete that circle a little bit more, like so, we are looking at, it's closer to port X, so it's going to be somewhere along this region here. So it's got to be on the left of the line, but inside that 5.5. Again, this length here is 5.5 centimeters, and we're going to label this area R. Then moving on to our last question, it says use a ruler and compass to answer this question. Point P is the same distance from AB and AD and 6 centimeters from D. So what we need to do here is we need to do an angle bisector, and we need to draw a circle of radius 6 centimeters from C. And we're looking for the intersection point of both that angle bisector and that circle. So again, it doesn't really matter which one you do first. So let's do the circle first. So I'm going to measure 6.5 centimeters, about there, from C, and I draw my circle. So it's going to be somewhere along this circle here. So now I need to do an angle bisector of this line here and AD. So it's that line there. So it's the angle bisector of this line and this line. So what I'm going to do is I'm going to set my compass up. Now it doesn't really matter what length you have it at, as long as you're not, whatever you feel comfortable. I'm going to go for this mark here and that mark there. And then where it hits the line, put the pin there, and I draw an arc in the middle. And I then, without adjusting the compass, which is the most important point, I look at where the points cross, and then from that intersection point here, I'm going to draw a line, and I'm looking for where the line crosses the circle, which is at this point here, and I'm going to label this P, and that is it.